And good morning, everyone. Dwayne here. Welcome to the Radical of Math. And after a little bit of a break due to that pesky thing called work, it's time once again for us to do some math together. So today, grab yourself a paper, pen or pencil. That's all you're allowed. No electronic aid, no nothing. And we're going to solve this analytic geometry question. And I'm a firm believer that in the United States, analytic geometry has been sacrificed for the sake of expediency and for other learning outcomes. And this problem really will expose who understands high school mathematics, college preparatory mathematics, and who doesn't. On my Twitter, I said I think 50% or more of US pre-calculus students cannot solve this problem. Now, for those who are international viewers, if you go, well, Dwayne, that's just the formula of point to line, what's the problem? That is not taught very often in US high schools. So for this, don't use it. Instead, do it another way. Here's the equation. Find said equation of the circle with the center at -3, 5 and tangent to the line 4x minus 3y minus 18 equals 0. Now, a lot of students at this point in the US will stare at this problem and go, I don't know what to do. So, what you got to start doing is asking yourself, what do I know? And what do I need? So I have a line. I have a circle. I know the general equation of both. That's what I know. But what do I need? I need some geometry. I'm definitely going to need some algebra. But also a picture. I need a picture. So, let's tackle the picture first. On our coordinate plane, the center of our circle is right there. It's in quadrant 2. But the other thing is we have a line, and it's a tangent. So, let's look at this line very carefully. Now, for some of you, this is very uncomfortable. It's not in the form you're used to, so manipulate it. This is standard form, or derivative of standard form, depending on your textbook. And what we want here is a form that we can immediately do things with. So, all I've done is put it in slope-intercept form. So y equals mx plus b. Let me put that down here. That way you are comfortable. Y equals mx plus b. Not a problem. So we now know it intersects at -6. So if I was to come down here and go 1, 2, 3, 4, 5, 6, we know that's an intercept. At 0, -6. We have a slope of 4/3. And if we set this to 0, 9/4. So we know 1, 2, 3, it's right there. And so we have a rough idea. There's our tangent line. Now we don't know where this circle meets it, but we have a picture. We have a picture. We know that the slope of the tangent is at 4/3. That's very important. So now what we're going to figure out is the geometry part of it. So we know all circles have a radius, a circumference, and a general form. So we know that the general form of a circle is that. Now in some textbooks they use H and K, A and B. I'm just using Greek letters for this. But the point is nevertheless the same. The center equals r squared, r being the radius. So obviously it's going to be very advantageous and necessary to figure out what the radius of the circle is, but we have a center. We have a center, and we already know that our equation must fit this. How do we know that? Because the problem tells us circle with a center. So you already know it's going to look like that. Now, here's where the geometry kicks in. Remember, if you have a circle, a radius hitting a tangent, there we go. The angle it creates is a right angle. So, because it's a right angle, it's an altitude, it's a perpendicular. Some textbooks call it a normal. They're all the same. Makes a right angle. So if our tangent line is at 4/3 slope, our radius is the negative reciprocal, which is -3/4. So we now have a slope of the radius, we have a center point, and now what we've realized is this point right here is going to be needed because we need the radius. We need the radius from here to here. So we got to find out the intersection point so we can calculate the radius. Here's where the algebra comes in. We have a line. So we have a point, we have a slope, so we're using that point, we're using the radius slope. So we now know B sub r, because we want to differentiate the radius line from the tangent line, is 11/4. So that means that the line in slope-intercept form is that. All right. So if I have these are my two lines. So in slope-intercept form, y sub t tangent line is that. line of the radial line is that. Notice they're at right angles. And we want an intersection point. That means these two things are equal. They're equal. So we want to find out what x is. Once we find out x, we're going to get y. Basic algebra 1 here. Bring all the x over, send over all of the constants. So this is 24 over 4 plus 11. And now we have to add this. So what I've done is the lowest common denominator of this fraction is 12, and I've just grouped it already. That's all I've done. And so there we go. 25/12 of x equals 35 over 4. So now you can say 25x equals 35/4 divided. We're just multiplying, correction, not 1/12, 12. This is wrong. I did not take the reciprocal correctly. So I'm multiplying everything by 12. And so now I have 25x equals 105. Because this cancels out. And when you reduce it, you now have x is 21/5. That is the x coordinate of the intersection point. So if you draw on the graph, that's why you have a graph, the x is right there, so we know y is way up here. All right, so we know what x is. Now we need to figure out y. So let's go back into the original equation. We know they must equal. So there you go. So 84/5 is that number. But this number can reduce. Negative. So this is a 3. It's a 3. Okay, let me check that here. Okay, that is not right. That's why I always have notes. That's why I always have notes. Because when you sit there and go, wait a minute, that's not right, it's because I added this instead of subtracting. This is 90 minus 84/5. Better. Divide by -3, that cancels out. That's correct. So we know our point of intersection is that. So it's right about there. So we now know our tangent. That's why we put this in dots. And that's why it's just a picture, it's not exact. Negative 2/5 right there. So we now know that is the radius, and that's the tangent line. We know the circle goes this way. There we go. So now we have a center and we have a point. We're going to use the distance formula. So negative 3 minus 21 over 5 squared plus 5 plus 2/5 squared. So minus and minus. And now what happens is this becomes negative 36 over 25 because it is squared plus 27 over 25 squared. So when you expand all of this, you're going to get 1296 plus 729 over 25. For some of you, this is the hardest part because you don't do calculations all that well. You're used to a calculator. Learn to do 2 by 2 multiplication quickly. Automaticity will definitely help you out. So this equals this. 2025 over 25. So the bottom number, because remember we have a radical of a fraction, so that equals this. So we know the bottom is 5. We know the bottom is 5. Now we got to figure out the top. Got to figure out the top. Well, we know it's divisible by 5. So 5, 4, 0, 5. So we can take out another 5. It's 81. So take another 5 out of that. Well, we know 81 is 9 squared. So we now have this beautiful reduction. So the square root of 5 squared is 5. So you have 5 times 9 over 5. So now we know the distance between the center and that point is 9. That's our radius. We know what that is. That's the radius. Radius is 9. So the equation of the circle. And do not be sloppy here with the signs. There's your equation. And I'll show you. There's my notes. We'll see how well that shows up on the video there. But there's my notes. So this problem has a little bit of everything. Has a little bit of geometry, a little bit of algebra. It has a little bit of thinking. It has some error. Notice I found a basic algebra error and went, no, that's not right, and redid it. My picture wasn't exactly accurate, but it gave me an idea. And that's the beautiful thing about a picture. Picture doesn't have to necessarily be accurate. It just gives you an idea. But nevertheless, we've arrived at the correct answer. Quantity x plus 3 squared plus the quantity y minus 5 squared equals 81. That is the equation of the circle. So anyway, I hope you like, follow, subscribe. We got a lot of content coming. I have some more commentaries coming up right now. We're going to be tackling some more things coming out of the National Council of Teacher Mathematics, the worthlessness of the American Mathematical Society. We're going to do some more math together. So stay tuned, and as always, take care of yourself, take care of one another. God bless. We'll see you next time.